sure you've heard the news. The skeletal system is more than just bones. It includes structures like the exoskeleton and endoskeleton, each playing a crucial role in the animal kingdom. Two key players in the skeletal system are bone and cartilage, each with its own unique properties and functions that are essential for our body's structure and movement. Bone, the hard, mineralized material we typically associate with skeletons, provides the strength and rigidity needed to support our weight and withstand impact, making it crucial for our daily activities. Composed primarily of calcium and phosphate, bone is a living tissue that is constantly being remodeled throughout our lives, adapting to stress and repairing itself.
Cartilage, on the other hand, is a flexible, rubbery tissue found in joints, ears, nose, and other parts of the body where flexibility is essential, and other parts of the body where flexibility is key for proper function and movement. Unlike bone, cartilage lacks blood vessels and nerves, relying on diffusion for nourishment, which affects its healing process. This unique characteristic makes cartilage slow to heal, as nutrients take longer to reach damaged areas, prolonging recovery time.
Despite their differences, bone and cartilage work together in perfect harmony, each complementing the other's function. Cartilage provides smooth surfaces for joints, allowing bones to glide over each other with minimal friction, ensuring smooth movement, while bone provides the structural support that allows us to move with strength and precision, enabling a wide range of activities.
Our understanding of the human skeleton has come a long way from the rudimentary sketches of ancient times. One pivotal figure who revolutionized our knowledge of anatomy was Andreas Vesalius, a 16th century Flemish physician often hailed as the father of modern anatomy. Vesalius challenged the prevailing anatomical theories of his time, which were largely based on the works of ancient Greek physician Galen. Galen, however, had based his anatomical descriptions on the dissection of animals, leading to numerous inaccuracies when applied to the human body.
Through meticulous dissections of human cadavers, Vesalius produced detailed anatomical drawings that corrected many of Galen's errors and provided a groundbreaking new understanding of the human body. His masterpiece, On the Fabric of the Human Body, published in 1543, was a landmark achievement in medical history, setting a new standard for anatomical accuracy and forever changing the way we study the human form. Section 5. Unlocking the Secrets of the Human Skeleton.
The human skeleton, a marvel of biological engineering, is composed of 206 bones that work in concert to provide support, protection, and mobility. These bones, far from being inert structures, are living tissues that constantly remodel and regenerate throughout our lives. We can divide the skeleton into two main parts: the axial skeleton and the appendicular skeleton.
The axial skeleton forms the central axis of the body, encompassing the skull, vertebral column, and ribcage. Think of it as the core of our skeletal framework, providing a sturdy base for the attachment of limbs and muscles.
The appendicular skeleton, as its name implies, consists of the bones of the limbs, arms and legs, and the girdles that attach them to the axial skeleton. This intricate network of bones allows us to walk, run, jump, and manipulate objects with our hands.
Section 6. The axial skeleton, our body's central support.
The axial skeleton, the cornerstone of our skeletal system, can be thought of as our body's central support beam, providing essential stability. Running from the top of our head to the base of our spine, it provides a framework for the attachment of muscles and protects vital organs such as the brain, heart, and lungs, ensuring their safety. This central pillar of support is further subdivided into three main parts: the skull, the vertebral column, and the ribcage, each with its unique function. Each of these components plays a crucial role in maintaining our structural integrity and safeguarding our internal organs from harm.
The skull, a complex bony structure, houses and protects the brain, our body's command center, from injury. The vertebral column, more commonly known as the spine, provides support and flexibility to the torso, allowing us to bend and twist with ease. The ribcage, a protective enclosure formed by ribs in the sternum, shields the heart and lungs from external forces, acting as a sturdy barrier. Section 7. A closer look at the skull, protecting our control center. The skull, a remarkable feat of natural engineering, serves as a protective vault for our most vital organ, the brain. Composed of 22 bones, the skull is a complex puzzle of interlocking plates that provide both strength and flexibility. We can divide the skull into two main parts, the cranium and the facial bones. The cranium, forming the rounded upper portion of the skull, encases and safeguards the brain. The facial bones, as their name suggests, make up the framework of the face, housing our sensory organs, eyes, nose, ears, and providing attachment points for the muscles that control facial expressions. These 22 bones, intricately joined together by immovable joints called sutures, provide a remarkable degree of protection for the delicate organ within. The skull also houses our sense organs, allowing us to interact with the world through sight, sound, smell, and taste. Section 8. The rib cage, guardian of the chest. The rib cage, a bony enclosure formed by ribs in the sternum or breastbone, acts as a protective barrier for the heart and lungs, two organs essential for life. Consisting of 12 pairs of ribs, the rib cage is a flexible structure that expands and contracts with each breath we take. The ribs, long, curved bones that extend from the thoracic vertebrae at the back to the sternum at the front, provide structural support and protection for the chest cavity. The first 7 pairs of ribs, known as true ribs, are directly attached to the sternum by costal cartilage. The remaining 5 pairs of ribs are called false ribs. Of these, the 8th, 9th, and 10th pairs are indirectly connected to the sternum through cartilage, while the 11th and 12th pairs, known as floating ribs, are not attached to the sternum at all. Section 8. The 5 regions of the spine. The vertebral column is divided into 5 distinct regions, each serving a unique purpose. First, the 7 cervical vertebrae in the neck support the head and allow for its wide range of motion. Next, the 12 thoracic vertebrae anchor the rib cage and protect vital organs. Below, the 5 lumbar vertebrae provide strength and flexibility for lifting. The 5 sacral vertebrae form the sacrum, a solid base in the hip region. Finally, the 4 coccygeal vertebrae, or tailbone, support sitting posture. These regions support the body and protect the spinal cord, ensuring efficient function. The appendicular skeleton includes the bones of the limbs and girdles. It is responsible for movement and interaction with the environment. This chapter will explore the various parts of the appendicular skeleton, including the pectoral girdle, pelvic girdle, and the bones of the arms and legs. First, the pectoral girdle, consisting of the clavicles and scapulae, provides attachment points for the muscles that move the shoulders and arms. Next, the pelvic girdle, formed by the ilium, ischium, and pubis, supports the weight of the upper body and provides attachment points for muscles. Moving on to the bones of the arms, we have the humerus in the upper arm, followed by the radius and ulna in the forearm. These bones enable a wide range of movements, from lifting to throwing. The hands are made up of the carpals, metacarpals, and phalanges, allowing for intricate tasks and dexterity. In the lower body, the femur is the longest and strongest bone, connecting the hip to the knee. Below the knee, the tibia and fibula support the body's weight and facilitate movement. The feet, composed of tarsals, metatarsals, and phalanges, provide balance and mobility. Together, the appendicular skeleton's components enable us to perform everyday activities, engage in sports, and explore the world around us. The parts of the appendicular skeleton include the pectoral girdle, which consists of the clavicle and scapula, the pelvic girdle, which includes the hip bones, and the bones of the upper and lower limbs. All the bones continuously remodel themselves, breaking down old bone and forming new bone in a process called bone remodeling. This allows bones to adapt to new stresses and repair themselves after injuries. Moreover, bones play a crucial role in producing blood cells. Inside the bone marrow, red blood cells, white blood cells, and platelets are created, vital for carrying oxygen, fighting infections, and clotting blood. Bones also act as storage banks for minerals. They store essential minerals such as calcium and phosphorus, releasing them into the bloodstream as needed to maintain vital function.